Do you have anything to ask in the previous lecture? From the previous lectures, anything? If not, then we will continue our discussion. So this is lecture number 3. And we are continuing our discussion on ray optics. Where I think we were discussing about reflection. And were we doing sheet?
Yes, sir.
We were doing the sheet questions. Sheet 1, class work problem. And I think I discussed one of the questions in a hurry last time. Was it understood?
Yes, sir.
Yes. I don't have to do it again now?
No, sir.
Good. Then what is the question number?
6.
Question number 6. What is the question? I have the sheet with me. You don't need a diagram for this. Actually, it's a question that you can do in 10 seconds. Can somebody give me an answer?
It's option B.
Option B, he says. What is the logic behind it?
Sir, the ones that are perpendicular cannot be changed. Perpendicular to the normal should not be changed. Ones that are parallel should be changed.
Yes. The mirror, so the question is something like this, that the mirror is lying on the xy plane, then the normal to it will be in the z direction. Yes? Then the component of object velocity, which is parallel to this normal, will be reversed, and the components which are perpendicular to it will remain unchanged. Then what is the normal vector direction? The normal vector is k cap. What is the object velocity? 2I minus 3j plus 4k. Plus 4k. Yes? Which components are perpendicular to this k cap? This I cap and j cap are perpendicular to k cap, right?
Yes, sir.
They will remain
Unchanged.
unchanged. What about this 4k cap? This is parallel to this?
Yes, sir.
This will reverse. Then what will be the image velocity look like?
2i
That will be 2i minus 3j minus 4k. Does it make sense to everyone? This was question number 6. Fairly easy. What about question number 7? This is interesting. And the diagram to it is something like this. Let's say this is your mirror. This angle is given. I think this angle is given to be 30 degrees. Okay. The object is falling with a 10 meter per second velocity. This is the coordinate system given to be I cap and j cap. And now the question is, find the image velocity vector. Try to do it. I'm giving you 3 minutes. And then I will discuss. I will start with the question at 12:03. Again, in this question, actually based on options itself, you can answer the question in 5-10 seconds.
Sir, option A.
Option A, he says. How many of you agree option A?
Yes.
Option A is the correct answer, just by looking into the signs. Can you imagine how the image velocity will look like?
Same.
Use imagination. Also get the answer formally as well. Try to get the full answer. Okay then, I'm starting with the question. And as I told you, you don't even have to do calculations. Based on options, it's very easy to conclude something. Understand this. If your object is going to fall downwards, then where will your image look like? It will look like that it is coming towards you. So there should be a component which is coming in this direction. There should be a component in plus j. Yes? Is your object going upwards or downwards? Will it go upwards or downwards? It's going like this, in this fashion. If I am running beside a mirror, then my image is running with me?
Yes.
Yes or no? So that means this has a tendency to go in this direction. The image will also have a tendency to go in this direction. Just by looking at this, then what is the components? The component should be plus and plus. Yes or no?
Yes.
And that is the first option.
But there are 2 plus and plus.
There,
C is also 5 root 3 plus 2 Jacob.
I may have made that option. But anyways, let's try to make the whole, do the whole solution, and then let's conclude something. Chalo. This is my BO vector. Yes, BO vector. What is the angle that it is making with here?
60 degrees.
That's 60 degrees. Do you remember one of the notes that I told you that image velocity vector and object velocity vector make the same angle with the mirror? Do you remember? I told you. Then what about this? Maybe you can anticipate the image velocity is coming like this. It's like this, image velocity. What is the angle here?
30.
30.
60.
It's 60, na? I just told you, theta same angle but nearly 60 degrees. Let's say I drop this. Then by alternate angles, what is this angle?
30.
Then what is the angle that the VI vector is making with the horizontal?
30.
Then what is the component along horizontal? That's cos 30. What about the component along vertical?
Sin
Sin 30. Everyone knows this is simple vectors. Then how should I write my vector? Acha, you know this key. The image speed and object speed is same.
Yes, sir.
In all cases. The magnitude, I already know the magnitude. Then I can write the vector directly. The vector is 10 cos 30 I cap plus sin 30 j cap. And what will this look like? Cos 30 is
root 3 by 2.
Is 5
5
root
root
3 I
3.
cap plus
5 Jacob.
Is it okay with everyone? How I wrote my vector? Good. If you are done with this, then go for question number 8. And for question number 8, I have to make the diagram. This is the diagram at hand. And I think they are asking to find the relative velocity, some kind of relative velocity. The velocity of the image as observed in mirror 1 relative to velocity of image as observed in mirror 2. Now we have 2 mirrors. How will you deal with it? I'm giving you 2-3 minutes to think and then we'll start.
Sir, is it option B?
Incorrect. Any other answers? Should I start or should I wait one more minute?
Wait.
Sir, option A.
Yes, that's correct. Show me how.
Sir, this is nothing but VL1 minus VL2 vectors.
And how is this cos 2 theta?
So because the image is making, the object is making theta, the image will make 2 theta. That there was a property that you told us yesterday.
This is the image. This angle is
This-
what? This
this
angle is the
angle-
angle between these two vectors.
Sir, but
Where are those two vectors? Can you show me where are? I remember what you are talking.
so 2 theta directly we've got that.
What do you have to find? There will be an image due to this
Here,
mirror.
here, and there will be another mirror here.
There will be another image due to this mirror.
uh,
Where are those vectors?
These
Show me
two.
those vectors.
the vector like this and the vector like this.
ये इसकी वजह से ये कैसा होएगा? That's clear. How will the image look like from the perspective of this mirror? Once you get that vector, then you have to find the angle between that vector. It is cos 2, it is 2 theta. But tell me how. Okay then. I'm starting with the question. Consider the two mirrors separately for now. What will be the image formed in mirror 1? It will be just as parallel to this. So you will have a vector like this, Vi1 vector. Image 1 vector. Yes? If this mirror were to be direct like straight like this, then how will your image look like? Your image will look like something like this now. Huh? Now when I rotate this mirror like this vector will also get rotated? Yes or no? If I rotate this angle by theta, then this gets rotated by some angle as well. Then how should my vectors look like? So one of the vectors, Vi1 vector, will be something like this. That is, I am sure with it. One of the other vectors may be something like this. Vi2 vector.
Wait, Sona.
Is it understood? If this is angle theta, then this is angle theta? Yes? What about this angle? Can somebody tell me what should this angle be?
2 theta.
2 theta. Think carefully. What will that angle be?
Theta never theta. Sir, theta because the angle made by the incident ray and the deflected ray will be equal.
The angle made by the incident ray. This is the angle that the incident ray is making. Let's say this is the normal. So ये angle कैसा बना रहा है?
Same.
This
That
is
is
theta. Then this should be 90 minus theta. This is 90 minus theta.
this
Therefore,
is
what
theta.
this?
Theta.
Yes, everyone understands this? So what is the angle between these two vectors then?
2 theta.
2 theta. The angle is equal to 2 theta. What do you have to find? You have to find a relative velocity. Yes or no? In the question they are asking relative velocity. They are asking to find the magnitude of it. That is vi1 minus vi2 vector, the magnitude. You have to find this. This is what is asked in the question. No? Find the velocity of the image created by 1 with respect to the image created by 2. Then how do you find the magnitude of p vector minus q vector?
Vector subtraction.
How do you find it?
Under root of q.
Under root of?
v1 square plus v2 square minus 2 v1 v2 cos theta.
Yes. So, don't you remember this? Under root of p square plus q square minus 2pq cos theta. And theta is what? The angle between the vectors. So, here VR will be, acha, object speed is equal to image speed, right? Doesn't matter how many mirrors are there, this is also one image, that is also one image. All the images will have the same speed. So, ये मैं डायरेक्ट लिख दूँ क्या? v square plus v square minus 2v square cos of 2 theta. Anyone, any problem with this statement? No? Are you okay, or should I write step by step everything? It's okay? Good. I can take this common. What is 1 minus cos 2 theta then?
Sin 2.
Idiots. 11th abhi there.
Sin square theta. 2 sin square theta.
2 sin square theta. Then if I take the root, what will I get? 2v sin theta. And this is the answer. Did you understand? Never forget about vectors. Your whole 11th and 12th standard physics is based on vectors. Everywhere you will find vectors. Okay? So this was question number 8. Question number 9 is a very interesting question, but we will not do that today. That involves two mirrors where there will be multiple reflections in between the mirrors. मैं diagram बना के दे देता हूँ उसका. Is this done or I'm making the diagram here? Question number 9 diagram. The diagram is something like this: 8 meter, 2 meter. Object is somewhere here. This is mirror M1. This is mirror M2. This is the situation given. You are standing in between two mirrors. How many images do you think there will be?
Infinite.
Infinite images in both of the mirrors. Huh? The question then asks to find the first three nearest images position. The question is find the first three nearest images position. What will be the first nearest image?
So
Can
is it
somebody
C?
guess?
2 meters.
This will be 2 meters just here. What will be the other ones? That is the interesting part. We will do that later.
8 meters.
Is it C?
Huh?
C.
What is the C option?
2, 18, 22.
Let me check. I don't remember exactly. Question number 9. Yes, it's C. But anyways, I will discuss these questions later on, not today. But it's a very interesting question. Question number 9, I will discuss in class some other day. Question number 10 is doable. Take it as a homework. And if you see, the rest of the question falls into the category of homework questions.
Sir, but it requires a diagram. 10 to 1.
Question number 10. Question number 9 was this. Show me the question. An object. You don't really need a diagram, but
I mean, to which side is the person standing?
I'm making the diagram of the figure. This is the diagram that we have. Okay? Take this diagram and do the question number 10 as a homework. You can leave question number 9 for now. I will discuss some other day. Rest of the questions are homework questions. Complete them as soon as possible. And if you find something difficult, then tell me. I will do those questions even in class. Okay? We are done with sheet number 1. Then let's start with something new now. We are done with the discussion of reflection in a plane mirror. Now we will start with the discussion of reflection from a spherical surface. ये इतना बैकग्राउंड नॉइस क्यों आ रहा है? Reflection from a spherical surface. What are the two spherical surfaces that we should consider?
Convex and concave.
Convex and concave. Good. Then do you know the surfaces are something like this? Let me make the diagram and then I will discuss. What is this mirror called, by the way?
Concave.
Concave. What about this one? Convex. Good. Why did I make this dotted lines? Because the way in which we consider a concave or a convex mirror is you can imagine a football and then slice some part of it. Maybe you have a football like this and then slice some part of it. That small part represents our convex or concave. So this dotted lines are just the imaginary extension. If you have a sphere, then obviously you have a center and a radius. Huh? What is the center called?
Center of curvature.
Center of curvature. Hopefully everyone knows this as well. These are basic terminologies. Center of curvature. What is this R called?
Radius of curvature.
Then what is the distance? That is the distance between C and P. That is the radius. Not writing? What is this line called? Anybody knows what is this line called?
Principal axis.
The principal axis. The line that passes through C and B is called the principal axis. What is this P called?
Pole.
That's the pole. What is that taken to be?
Center of the mirror.
That is taken to be the origin in all our calculations. If you remember, I told in sign conventions. The same terminology follows for there as well. Okay? Please make the diagrams with pencil and scale. I should not find diagrams made from pen. I will tear the page. Good. This is called a converging, and not converging, but rather this is called concave mirror. This is called a convex mirror. Just for fun, can you tell me, if I were to shine a light, from where should I shine the light? Should I shine a light from here or there? It only makes sense that I should shine the light from the in front of the glass, not the. What would be the point of that? So ये इधर से अगर चलूँगा मैं, let's say I have a source here, the incident rays are going in this direction. When I calculate distances, then they are calculated with respect to what?
Incident. No, pole.
They are always calculated with respect to pole. Remember that. When I calculate this R, I should not find CP, I should find PC. Yes or no? And what is the direction in which I should calculate? In this direction. If you remember sign conventions, then can you tell me, is the R greater than 0 or less than 0?
Less than 0.
Less than 0.
In this case, greater than 0.
What is the direction of this incident ray? In this direction. In which direction are we calculating R? In this direction. Same direction? So R greater than 0 or less than 0?
Greater than 0.
That's one of the characteristic features of convex mirror, that you have radius of curvature to be positive. What about for concave? Where should I put my source now?
Left side.
And the other side, as what a same person does. You know? And now how should I take CP or PC?
PC.
PC again. Then बताओ इधर R कैसा होगा?
Less than 0.
It will be less than 0. Is it understood? Then for a concave mirror, you will always have radius of curvature negative. This is one of the key characteristic features. And for a convex mirror, you will have a positive. Am I going too fast here?
No, sir.
It's all stuff that you have
No,
seen
sir.
already, no? Good. We are in the spherical surface section. We have to deal with certain terms, and there is an approximation that is very useful to us. That's called the paraxial approximation. Let me do that. So is this done? This is done. Can I go forward? I will wait one more minute. चलो जल्दी जल्दी. Are you two understanding? Good. If you find something that you are not understanding, then tell me, please. Otherwise, there is no point to the lecture. Can I go forward?
Yes, sir.
Let's talk about this paraxial rays and paraxial approximation. Imagine you have a concave mirror like this. Let's say you have a concave mirror. Something like this. This mirror is not that big, huh? Maybe this mirror may be of this size or something. If let's say I have an object which is placed here, it's making some angle theta, and this theta can be 60 degrees, 75 degrees, whatever. It can be a huge angle. To make such a big angle, how close do you have to be? What do you think?
Close.
You have to be pretty close, no?
Yes.
You have a mirror like this. You have to be pretty close to make this angle, this huge angle. Normally we have objects at what distances? at good enough distances, maybe 10 meter, 5 meter, 10 kilometer or something, then if you take the angle at that point, how will the angle look like? This is my theta now. Is this big?
No.
It's never big. All the angles with respect to principal axis, the angles that we take typically, because the mirror is not that big, even if you have the glasses or even this, if you take this to be a circular section, and that is, it's very small, it doesn't have a big curvature as compared to the length that we are talking about. So it will always have very, very small angles. Under small angle, do you know this thing called small angle approximation?
Yes.
Huh?
Yes.
What is small angle approximation? Can somebody tell me?
Sin theta equals theta.
Small angle approximation, sin theta
Is equals
is
to
approximately equal to theta. What about tan theta? That's
0.
also theta. What about cos theta?
1.
That's approximately 1. This is a small angle approximation. That theta, how it is measured? In what units?
Radians.
Radians, not in degrees. Radians. Measured in radians. So what can we apply? Whenever we are talking about, in general in ray optics, we can apply this approximation. This is a good enough approximation, and you can apply this as well. So I will keep on using this repeatedly, and you should understand why I am doing this. Okay? There's another thing that I have to highlight. Let's say the object is here. Let's say this is object A. This is point A, this is B, and this is B. Yes? If I am too far away from this curve, then this curve will look as good as a plane to me?
Yes.
Yes or no?
Yes.
This AB distance, if I consider, this AB and this AP will approximately overlap for me. So I can make the approximation that AB is approximately equal to AP. Do you understand? Achha, that AB and not that AB, sir. Rather this perpendicular. This perpendicular. That perpendicular and that is approximately same. This is what I am talking about. This distance AB and this distance AB are approximately same. The curve can be approximately taken to be plane. I will use this as well. This is also under the approximation, that's called paraxial approximation. So what is the approximation then? AB approximately equal to AB. Why did I use this? You will understand in a minute when I do the mirror derivation that I will often use triangles. Okay, I will often use triangles and distances will be measured from the pole. That is our convention. Distances measured from pole. But often I will not measure from the pole but rather from this perpendicular. And I will say that this distance and this distance are approximately same. The distance BP is negligible. Okay? You will understand in a minute what I am doing. This along with this is called a paraxial approximation. Did you understand what I am saying?
Yes, sir.
Whatever I am doing here. What is a paraxial ray then? A paraxial ray, a ray that makes, please write with me, small angles, very small angles with the principal axis. Those are paraxial rays. And this approximation that I have written, this is called the paraxial approximation. I will keep on using it throughout the ray optics. Please remember why I am doing it. Okay? Can I go forward? Keep it as a note. A thing that to remember. let's talk about some of the rules of the ray diagrams. Okay, if you remember, when we had the plane mirror, then it was a very simple case. You put a plane mirror, you put an object in front of the plane mirror, you already had a relation between object distance and image distance. And you can already say where will the image be. Okay? But for a spherical mirror, it's a totally different case. If you put the object at different distances, then the relation is not that simple as u equal to minus v. It's something different. Okay? We'll try to see by ray diagrams and then we'll derive an equation for it. So first you have to understand the rules of making the ray diagrams. So I think you already are familiar with this as well. Rules for ray diagrams. Okay? If you place an object at infinity, then what happens? Where will the image be created?
Focus. It
Between C and D. Focus.
At focus. Yes or no?
Yes.
If you place your object at infinity, your image will be made at focus. Everyone knows this?
Yes.
If you place your object at focus, then where will the image be created?
Infinity.
If you place if your rays are going through the center of curvature, then how will they come back? It retraces its path. You know this?
Yes.
Everyone knows? I'm going to make the diagrams. If you know this, then do it quickly with me. The diagrams will be something like this. Chalo. ये है pole, this is center. Rays are coming like this. Acha, I did not use this word focus up until now. So hopefully you have a little bit of understanding what is the focus. For now, what is focus? The point through which the rays that are coming parallel to principal axis will reflect back. Okay? That is the only thing for now. It's just a point for us. Later on we will see its significance. Is this diagram complete? Correct? Where should I put my center of curvature? Left or right?
Right.
Right, na? You create a circle in this direction. अरे इधर circle बनेगा ना कि इधर बनेगा circle? Right? So it should be center of curvature should be here. And it's somewhere here. What kind of image can you comment upon the nature of this image?
Virtual image.
Virtual image. Yes? This is the first. Do I have to write it the rays coming from infinity then
No,
they
sir.
pass through focus? The diagram is clear enough now?
Yes.
I think you will understand it. The rays passing through focus, how will they move like?
Parallel to the principal axis.
Yes?
Yes.
Something like this. What about here? Yes? What about the third one then? Are these diagrams done? The first one at least? 10th में भी पढ़ा था ना ये सब चीजें? These are nothing new to you. You have seen these diagrams, right? For those whose notes are incomplete and who are absent for 1-2 days or whatever, I need your notes completed by tomorrow. I will check it. Understood? It's not a straight line, but make it better in your book. Are the rules clear for everyone? These are the rules that we will follow. In every ray diagram, we will just follow these 3 rules and we will be able to make all the possible diagrams. It's fairly simple task. Can I start with the diagrams, the actual diagrams?
No, sir.
Okay, I will wait 2 more minutes and then I will start. Be a little quick. Understanding? Yeah? If anybody has difficulty in understanding, then ask. What do you? We are putting our source here. Wherever, whatever your direction of incident ray is, do all the calculations with this. If your ray is coming like this direction is positive. If your ray is coming like this direction is positive. Depends on your incident ray. Incident ray source either ऐसा, either एक source ऐसे from the pole always. Pole is taken as the origin. You do all the calculations in coordinate geometry from origin, na? Shall I start then? Bolo. Okay then, I am starting with it. Ray diagrams. Yes? And let's make for concave mirror first. For concave mirror. The first position that I will consider, so understand what I am about to do. I will have a concave mirror. यहाँ पे there will be a pole, a focus, a center. What is my aim? Try to understand where will my image form based on where my object is. I will keep on changing my position of the object and try to understand where my image will be. So there can be many positions now. Maybe my object is placed at infinity. Maybe it is placed just beyond C. Maybe it is placed just at C. Maybe it is placed in between them, here or here. These are my possible positions of the object. Yes? So I will keep on considering them and make the ray diagrams. Is it understood? Let's take the case one. Object, and please be a little fast. Please try to be with me. Yeah? Please. At infinity. If your object is placed at infinity, then from where will the rays come? From infinity. So it passes through focus. This is my object AB. Can you comment upon the nature of the image?
Real and
It will be a real image. What about the size?
point size.
Its point size is highly diminished. What about the erectness or the
Erect.
yes, it is going to be erect. So real, point size, and erect. Is it understood? Case 2. Object beyond C. If I place my object beyond C, something like this is my object AB. Let's say the rays are coming like this. Let me take any two rays will do. Let me take one of the rays parallel to principal axis and the other passing through the focus. ये कैसा आएगा? Yes or no? And the other will go like this. Yes, I should make the arrows. Where is my object located? Between C and F. This should be E prime, E prime. That's being a little messy. And let me change my color. E prime, A prime. Can you comment upon the nature of the image? The nature?
It is inversed and
It's real firstly. It's diminished. It's diminished. Can you see that it's diminished?
Yes.
And it's inverted. Real, diminished, and inverted image. Do you understand? Yes? Case 3. Now where should I put my object? At C. Yes or no? What can be two rays that I can consider here? One parallel to principal axis, one passing through focus. Again the same thing. ऐसे ही consider करो. And if I consider, then roughly what do I find? I find my object in the image something like this. Just so if I put my object at C, my image will be at C again. What about the size?
Same.
Same size. And what about
Real and inverted.
inverted? Yes. So what should I write here?
Real same size and
Real of same size and inverted image. Is it understood? It's not a big deal to make the ray diagrams. Choose any two rays from the three rays that I have talked about. You will get the ray diagram. Case number 4. Now what should be the position of the object?
Between C and F.
Between C and F. Am I going too fast?
No.
It's all understood now. You already have seen these things. Now कोई no yes बोल रहा है? कोई बात नहीं. Minority. Can you tell me how the image will be? So पहले मैं बना देता हूँ ये ray diagram. One of the rays going like this. What other ray can I choose? Maybe I can choose this another ray. A same. How my image is? Can somebody tell me now?
real
Does it look enlarged to you?
yes.
Yes, good. तो ये हो जाएगा A B B prime A prime, and the nature will be something like real enlarged and inverted. Can you see one thing? That in all the cases that I have done up until now for concave mirror, we are always finding real images. Always finding real images. Let's try to see till where it will be, till where it will hold. Can I go to case number 5? Is case number 3 done? Where should I place my object now?
At F.
At F. Let's say this is my object. Can you tell me which two rays should I consider? Can somebody tell me?
One to the principal.
One parallel to principal axis, let's say.
And one passing touching P.
One passing through C.
Yes.
ऐसा ही कुछ होना चाहिए ना?
Or we can take it with P.
हाँ.
Ray coming back from pole.
Let me make this a little better. अरे I'm missing it everywhere. I want to show that it keeps on increasing the distance. So it's something that goes and then comes back.
So we can take that from here. We can take that from P also.
From P. From P if you take, it's okay. You will follow the laws of reflection. Achha, I should have told you this, the fourth rule, that if you have the ray at any angle, then it will follow the laws of reflection and then reflect back. Anyways, Achha, it doesn't.
Pole.
It runs parallel. parallel. So if you place your object at focus, the image will be formed at infinity. Yes? Is this understood? Good. Case number 6. So where should I place my object now?
Between P and F.
Object between P and F. That's all right. If I put my object between P and F, A, B, now what do you think? Which range should I consider?
Parallel and two pole.
A parallel to principal axis, let's say, goes like this. Anything else?
Pole.
Maybe through, you can take one of the poles or you can take this center of curvature as well. Okay? Are these rays ever going to meet?
No.
Not here. But if I were to extend them backwards,
They will.
they do meet somewhere and they create an image. What is the nature of this image now?
Virtual.
It's virtual and enlarged, highly enlarged, and
Direct.
it's direct. Very good. ये केस का लिखा था ना image at infinity. You can't comment upon any other thing. And we are done with the ray diagrams. Did you understand? These are very simple diagrams. Choose any two rays. Many people were saying take the rays that are hitting at the pole, and that is also good enough. You can take those rays and you will be able to do it. Not a big deal. Okay? So we found something different this time if you actually look into this. We never find a relation like u equal to minus v. Are we finding something like that? No. Ye positions are so different. So the relation between u and v is not going to be as simple as we found in plane mirror. Okay? And for imagination we have ray diagrams. But we need a formula at least to actually calculate if I put my object anywhere, then where will my image be created? This question should be answered, right? That we will answer by something called as a mirrors formula. And I will derive it in a moment. But ये concave का हो गया सबका? हाँ ठीक है. ये बताओ ये होगा क्या? I want to make a table जहाँ पे सब condensed everything is written. Can I make it? Yes. What was the size that we found? When we find it's point size, right? And real. Don't talk. When I go closer beyond C, then where I found my image? Between C and F, na? Between C and F. What was the size? Anybody remembers?
Diminished.
Diminished. What was the nature?
virtual and
Virtual?
no, sorry.
Real and inverted. Okay. What about at C?
At
At C.
same
Same size. Real and inverted. What about between C and F?
beyond C.
Beyond C. Size?
Enlarged.
Enlarged. And this? Real and inverted. What about
At
at F? At
infinity.
infinity.
High
This is just at infinity like it. And now between P and F? Behind mirror. Behind mirror.
Highly
Enlarged. And this is
virtual.
virtual and indirect. This is the table. And if you look into this carefully, there is a pattern. You stand at infinity, you'll get the image at focus. You stand at focus, you'll get the image at infinity. Stand at beyond C, between C and F. Stand between C and F, you'll get beyond C. At C at C. This is the only odd case between P and F. Then there exists a case in which you get a virtual image for this concave mirror. So you can't make a general statement that you will always get a real image. Is it understood? So please make the table. Is it understood? I did not mess up here, na somewhere. Hopefully. Concave mirror is done. I have to do convex as well. Convex mirror we will only consider two cases. So can I start with those cases? Yes. This table is done. Can you make that table yourself? चलो ठीक है बना लो. Nice G. Not writing.
My notes are.
You'll do it yourself.
My notes are. I'll be done by today.
I should find it tomorrow completed.
Yes.
Good. How many of you have notes incomplete? अरे वाह. ठीक है. I'll come up to you tomorrow. And I will ask. If I find incomplete notes, then don't sit in my lectures. Complete the notes and then revise and then come. Don't just come inside the lecture. Our Are you still writing rules for ray diagrams?
No sir, completely my study also.
ये idiot है क्या?
Sir, pencil.
पेंसिल खरीदा नहीं है क्या? कल नहीं दिखी पेंसिल तो देखो। ये पेन से डायग्राम होना है। कल तक नहीं मिला। चलो, I'm done with this. Are you done? Such a huge response. So concave, convex, or convex mirrors. For convex mirrors, I will consider two cases. Object placed at infinity, I think you already know where will the image be. And then object placed beyond C. So what is the case one? Okay. Save an eye. Let's say this is my object 80. Rays are coming like this. They go like this. ये इतना background noise क्यों हो रहा है ये? सोने क्या आता है क्या इधर? पानी मारूं पे? Can you comment upon the nature?
Virtual and points.
At least we can say virtual and point size and direct. Okay. What is the case number 2 then? Object beyond C. Is it still recording? Okay. So object beyond C. Let me see it once. Background mess up. One of the rays can come from infinity, go through focus, and one of the rays can pass through center of curvature. Yes. So wait. Doing something wrong. Let's leave this case for now. I'm forgetting something.
It will get reflected
Have some
see,
space for
with
this.
an equal angle. Then pole see it will
Yeah,
go
between
back.
P and
It
F.
will be diminished.
I think it should be beyond C के लिए between C and F होना चाहिए.
P and
The end.
that is correct what you did.
So it was correct.
It was correct.
Hmm? हाँ
and the first case will be at
हाँ हाँ
तो second वाला P के आगे रहेगा
ऑब्जेक्ट P के आगे रहेगा
No, even if it's like anywhere except infinity, the image is going to be between P and L.
P and F.
C and X.
P and L.
हाँ. I've only
An object is placed anywhere, huh?
Yes.
Anywhere, and how should I consider my second way?
You can take it to the center of curvature or from P.
But then if I take the center of curvature, then it will pass like this.
Not necessarily, you can tilt it.
Bolo.
So it's not necessary that C line should be like that. You can tilt it like this as well. As long
But
as
it
it's
should pass through C always. Huh?
yes.
But maybe you
Like
can consider one path like hitting the pole.
yeah, or you can just take the pole.
And it will go like this.
It is between
Between P and L. Sir, and also
makes sense.
Between C wala line, right?
yeah, like you can tilt it. It does not have to be like that.
Maybe I'm missing something here. But anyways, the main thing is the image form will be virtual.
Yeah.
Yes?
Same. The straight plane.
Second way towards focus. One line I consider. One of the lines you are saying to consider like this. You can consider it. It's not a big deal. You can consider one of the lines passing through the focus. Then you will have a point size.
Should the line be drawn to the object?
Yes.
Object option. We can do
तो
it.
ये
Top of the object.
थोड़ा सा नीचे बनाना पड़ेगा. अब हो गया? Is it okay now? Yes. Case 2. Between what?
Infinity and pole.
Yes. Anywhere you will find this virtual and erect image.
Scaling.
The main conclusion is this,
Scale.
that it does not matter where you put your object. For a convex mirror, you will always find a virtual image. Yes, virtual and erect. So let me write it as a
I
note.
need it.
For convex mirror, the image is always virtual and erect. Is it okay?
So
Yes.
you can also draw the line from C like this.
From the?
For C, like you can just draw a line.
Yes, you can use it. This way I was missing. Anyways, at least some kind of representation is there. This angle and this angle will be the same. Huh? Maybe my drawing is not that good, but angles should be same. They follow the laws of reflection. Are the ray diagrams that I discussed today okay? Yes. Now that we have a diagrammatic approach, we also want some kind of formula to actually calculate wherever I put my object, where should I find my image. That will be the mirror formula, and not today, but in the next lecture I will derive it. And then we will have a discussion on magnification, and a discussion on object and image velocity. Yes? After that, the reflection part will be done, and I will also share with you the sheet number 2. We will do that sheet and then we will be done with reflection. Then we will go to the topic of refraction. Maybe 1 or 1.5 more lectures for reflection. So nothing more for today. Okay, one question.